Hello everybody, my name is Gary and welcome to my first video. Today we will be talking about exponent laws. Exponent laws is one of, if not the most important part of math, especially going to the higher levels in high school where I'm at. And it's pretty much the fundamentals of everything. So basically like your ABCs, but for math. So, without further ado, let's jump right in. First of all, what is an exponent? An exponent is basically this bad boy. This thing over here. This 3 is what we call an exponent. It basically tells us how many times a number is multiplied by itself. So, like a shortcut to this. So if we had 2 to the power of 4, it's basically the same as saying 2 times 2 times 2 times 2. That's pretty straightforward. You should already know that if you are watching this video. If not, please go watch a different video first, learn about that, and come back here. And the exponent rule is pretty self-explanatory. So over here, ax times a to the y gives us a to the x plus y. Basically, if we have the same coefficients or bases and different exponents and it's in a multiplication equation, we can simplify this by simply adding the two exponents together like this, which would give us 2 to the power of 5. And this only works when the coefficient or the base are the same. So if we had 3 to the power of 2 times 2 to the power of 2, this would not give us 6 to the power of 4. That would be wrong. Instead, this would give us 9 times 4, which is a completely different answer than 6 to the power of 4. So just keep in mind that the coefficients or the base must be the same. The exponents, whatever, they can be any number. Let's say 2 to the power of 100 times 2 to the power of 300. This would give us 2 to the power of 400. Oops, that's an extra 0 according to exponent laws. While we're here, there are 6 to 7 exponent laws. Some people wouldn't really consider this one, number 4 one, because it's pretty easy. But we'll get into that in a bit. So let's move on to our second exponent law. It's basically the same as the first one, except with division. So instead of adding the two coefficients, we subtract the two coefficients. And this would give us 2 to the 1. That's pretty self-explanatory. Let's give an example. 4 to the power of 16 divided by 4 to the power of 4. This would be the same as 4 to the power of 16 minus 4, which would give us 4 to the power of 12. Same thing, the coefficients need to be the same, otherwise this would not work out. Simple enough. Let's move on to the next exponent rule, which is slightly harder in my opinion, but not too bad. Number 3. Ax bracket bracket to the y equals a the x multiplied by y. So what does this mean? Our coefficient on the inside with the x is going to get multiplied by whatever coefficient, by whatever exponent we have on the outside. y. So for example, if we have 2 to the power of 2 on the inside and 2 on the outside, you would think you put this 2 in here as well, but you actually do not. Instead, you take this 2 and you just multiply it by the inside exponent, giving us 2 to the power of 4, not 4 to the power of 4. That would be wrong. That's basically it. It's pretty self-explanatory as well. You just multiply whatever's on the outside by the inside, and you keep the coefficients the same. Next, number 4. Yes, the one that shouldn't really be in law, but it's good to remember. Basically, this one states that anything to the power of 0 equals 1. So let's say we have a big number like whatever this is. Anything, this or negative a million or whatever to the power of 0 will always give you 1, no matter what. Just remember this and you will be good. Next, number 5. This one, great. A over x bracket to the x. What does this give us? Oh, oops, I wrote this wrong. This is b. So we have two numbers on the inside. Let's say we get 1 over 2 to the something power. Since these two are in brackets, we distribute this power into both of these. So, for example, if we had 1 over 2 to the power of 2, we would put this 2 into both, giving us 1 to the 2 over 2 to the 2, which equals 1 over 4. That explains that rule pretty well, I believe. It's just you give whatever is on the outside, whatever exponent, and distribute it to both the numerator and the denominator on the inside, and solve from there. Next, let's get into exponent rule number 6. This one. This one's a slightly more challenging. So, what do you do if you have a negative exponent? Well, would it just be, let's say, 2 to the power of negative 2? Would it just be 2 times negative 2? If you think that the answer to this would be negative 4, then you are wrong. Yep, that is unfortunately not as simple as it seems. So, how do we do this? If we look over here at exponent rule number 6, a or any number to the negative power of anything gives us a reciprocal 1 over the coefficient with a positive power. So, for example, if we use the same example from earlier, 2 to the power of negative 2, instead of negative 4, we would get 1 over 2 to the power of 2, which equals 1 over 4. Yeah, this one is slightly more challenging, but you just gotta remember to put a 1 on top and the coefficient along with the exponent in the denominator, and change the negative to a positive. Other than that, it's pretty simple. Okay, just to test you, do this one on your own. I'm pretty sure you don't even need a paper for this one. Just pause the video and do this and see if you get it right. So 3 to the negative 2. What do you get? I'll give you 5 seconds. If you said 1 over 9, you would be correct. Good job. You have now mastered 6 of the exponent laws. Now, one last one. This one would probably be the most challenging, but you wouldn't really see this one until later in high school. So, if you're just getting to grade 9 or grade 8 or even grade 10, you don't really see this one that much, but it's good to know. So, what do you do if the power is a fraction? You guessed it, whatever this is. Basically, the a, or any number, or the coefficient gets put in a square root along with the x as the top power, and you move the y out. I don't really have too good of an example for this one, but an example would be, let's say you get 49 to the half power. You would get root 49 to the 2, and you would solve from there. Yeah, that's every single exponent law. This is my first video, so sorry if it took a long time for me to explain everything. I would try my best to be more clear and faster in the future, but I hope this was helpful and informative, and if you like, you can leave a like on this video. You get it? No? Sorry.